Tertiary treatment. Tertiary treatment is the removal of dissolved solids, residual suspended solids and microbes, and trace metals using ultrafiltration membrane vessels, ion exchange filtration system, thermal process. What is a membrane? What is membrane filtration? Membrane filtration is a physical separation process that uses a semi-permeable membrane to separate particles and impurities from a fluid. The membrane acts as a selective barrier, allowing the passage of certain particles while blocking others based on their size and charge. The feed is the water to be treated by the membrane. The material that passes through the membrane is called the permeate, whereas the material that is retained in the feed and rejected by the membrane is called the retentate. Membranes can be porous or non-porous. For porous membranes, particles lower than the pore size of a membrane would pass through the membrane. The separation mechanism in porous membranes is size exclusion mechanism, whereby particles are separated based on their sizes. For non-porous membranes, the membrane pore sizes are too small for most particles to pass through. For example, reverse osmosis membranes. The separation mechanism in non-porous membranes is solution diffusion mechanism, whereby the product, e.g., water, is dissolved in the membrane and diffuses through the membrane to the permeate side. Some porous and non-porous membranes are also electrically conducting, whereby particles are separated by attraction to repulsion from the membrane through a mechanism known as Donin exclusion. Classification of membranes based on pore size. Based on pore size, membranes are classified as microfiltration, ultrafiltration, nanofiltration, and reverse osmosis membranes. These membranes are used for membrane operations. Hydrophilic and hydrophobic membrane. Membranes can also be classified based on whether they attract water or repel it. Hydrophilic membranes are membranes that attract water molecules or have a high affinity for water molecules. Hydrophilic literally means water-loving. These membranes are designed to repel nonpolar or hydrophobic substances, such as oils and fats, while allowing polar or hydrophilic substances such as water and small molecules to pass through. They are commonly used in applications that allow water to pass a membrane as the permeate. Examples of hydrophilic membrane materials are polyamide, polyvinyl alcohol, cellulose acetate, and polyethylene oxide. Hydrophobic membranes are the membranes that repel water molecules or have low affinity for water molecules. Hydrophobic literally means water-repelling. They are commonly used in applications that reject water and allow nonpolar materials to pass through the membrane. For example, in gas separation, oil-water separation, and the removal of volatile organic compounds from air streams. Hydrophobic membranes are typically made of materials that have a low surface energy, such as polyolefins, e.g., polyethylene, polypropylene, fluoropolymers, e.g., polytetrafluoroethylene, and silicone rubber. Driving force. The driving force for pressure-based membrane separation process is the difference in pressure between the two sides of the membrane, P, which forces water and other small molecules through the membrane as the permeate while retaining larger particles and impurities in the retentate. Types of membrane material. 1. Polymeric membranes. Polymeric membranes are made of synthetic polymers. These membranes are widely used in water treatment due to their high selectivity, durability, and cost-effectiveness. Polymeric membranes are available in different pore sizes. Examples of polymers used in these membranes are polysulfone, PSU, polyamide, PA, polyethersulfone, PES, polyvinyl chloride, PVC, polyvinylidene fluoride, PVDF, polyethylene, PE, polybenzimidazole, PBA, polypropylene, PP, polyethersulfone amide, PESA, polyacrylonitrile, PAN, cellulose acetate, CA, polyvinyl alcohol, PVA, polyethylenamine, PEIT, polyamide, PEIT, polyethylene oxide, PEO, polytetrafluoroethylene, PTFE, and so on. 2. Ceramic membranes. Ceramic membranes are made of the oxides, nitrides, and carbides of inorganic materials such as alumina, titania, zirconia, boron nitride, and silicon carbide. These membranes are highly durable and resistant to high temperatures and harsh chemicals. Ceramic membranes are commonly used in wastewater treatment, brine treatment, and industrial processes due to their ability to remove a wide range of contaminants under harsh operating conditions, that is, under high temperature and presence of corrosive chemicals. 3. Mixed matrix membranes. A mixed matrix membrane consists of a continuous polymer phase and a solid phase. The solid phase can be an inorganic, metallic, ceramic, or even an organic solid material. So, a mixed matrix membrane is a membrane formed by incorporating a solid phase in a continuous polymer matrix, such that the advantages of both the polymeric matrix and solid particles can be combined in the membrane.